Kia ora. I'm Elliot Sawyer. I'm a senior Silverstripe developer at Catalyst IT based in Wellington, New Zealand. I'm a full-stack developer that predominantly works on Silverstripe websites, but also on other content management systems. I'm passionate about offering functional, highly accessible websites to our clients, while also offering excellent search experiences to all of our users, from customers down to the content authors themselves. By the way, this is an actual Twitter ad that initially caught my eye and drew my interest to TypeSense. I hope it works for you too. This talk will feature QR codes that will appear on the slide, so if you want to view more information, you can snap it with your mobile. Just a little bit about myself. I was born and raised in the United States, and I've been working in website design and development since I was a teenager. I have a computer science degree, and I've been working with search engines since 2004, and I moved to New Zealand in 2010. I mainly worked with full-text database search and Sawyer, but I've also worked with a number of different search products throughout my career. Prior to my work with Catalyst, I worked at Silverstripe for nearly 5 years, where I was well known for my experience with working with Sawyer. They called me the Sawyer champion. I've worked with a variety of different clients, ranging from banking websites, electricity vendors, government agencies, the New Zealand Census, and even a cryptocurrency exchange. As you can imagine, when you deal with large amounts of data, searching it efficiently is a necessity, and delivering a performant, high-quality search is essential for your customers and your business. TypeSense is a search engine that offers search-as-you-type experience across millions of records nearly instantaneously. It is a fast, typo-tolerant, in-memory fuzzy search engine providing a delightful search experience for your end users. It is an open-source alternative to Algolia and an alternative to Elasticsearch and Sawyer. It is intuitive to use and simple to set up, configure, and deploy in a variety of different ways. I will demonstrate and explain how you can use TypeSense in your own projects, talk about the open source module I've created to work with it, and where you can go for more help and resources. So let me start with a demonstration. Maybe you have heard about TypeSense before, but reading words is not really your thing, and you just want someone to show you in a few seconds how it can add value to your life. They've got you covered right here on the home page. This is TypeSense's homepage, and they have embedded a recipe search widget front and center at the top of their page. I actually use this quite a bit myself. My family is all vegetarian, and I am not. So sometimes I just need to find a really quick vegetarian recipe. So I'm going to search for vegan, and as you can see, you see an immediate response when someone starts to search for vegan recipes. If they want a stroganoff, it provides results before they even finish typing the full word. If they want to make some cookies for dessert, they can just click it up and feed themselves and their children some cookies. This instantaneous search-as-you-type experience that guides users to discover new and relevant information as quickly as possible is what TypeSense is designed from the ground up to do for your website. I have written a Silverstripe module to integrate with this product, and later in the talk I will show you what I have built with it and how you can do it too. So at a very high level, what can you do with TypeSense? The killer feature of TypeSense is its ability to instantaneously search millions of records faster than you can type whatever it is that you are looking for. This enables sub-millisecond response times by storing itself in RAM, while also taking advantage of multi-threading and GPU capabilities if either of them is available. TypeSense offers some nifty and clever features out of the box, such as curated search results, synonyms, and analytics. A decentralized dashboard is available that you can use to manipulate your collections and view your loaded data, while also allowing you to change and alter your schema directly without involving a developer. These features empower your content authors to take control of the information that they know best, which in turn allows their users to comfortably search the information that is presented to them. I will talk more about these features and more later in this talk. Once indexed, TypeSense stores its entire optimized index in memory. Because everything is stored in available RAM, this allows for blazing fast, often sub-millisecond response times, which enables TypeSense to return results almost faster than you can type. TypeSense is optimized for performance, but also for ease of operations. Its clustering abilities allow it to be distributed geographically using peering technology similar to BitTorrent. which enables TypeSense to distribute its load to where it is needed the most. The schema to define a collection is written in JSON and very intuitive for a developer to understand and use quickly. TypeSense can be downloaded from their website in a variety of different ways, including a containerized Docker application to a simple binary that can be run on a variety of different architectures. The documentation is clear, it's straightforward, it's easy to understand, and of course, fully searchable with TypeSense itself. TypeSense was originally created by Jason Bosco and Kishore Nalan. They started working on the project in late 2015 and open sourced it in 2018. The company is headquartered in Houston, Texas, but the team is fully remote and distributed around the world. It was born out of frustration with existing search products, which would rather have a steep learning curve and a very heavy operational burden, or were proprietary, expensive, and inaccessible to startups that are trying to run a company on a shoestring budget. The software was written from scratch in C++ and optimized for highly performant in-memory searches. Both Kishore and Jason run the company and develop the product together with a very small team of engineers. They communicate very openly with the community on their Slack channel and community message boards, while also offering paid support and hosting through TypeSense Cloud. TypeSense is free in every sense of the word. Anybody can obtain and use a copy of the software on their own server at no additional charge, while also integrating it into their own hosting if they would prefer. It is licensed under GNU Public License version 3 and distributed freely on GitHub with an active issues board that is regularly updated against a published roadmap to keep their users up to date on the latest developments in the product. The company prefers to sell search instead of stocks and focuses on offering excellent search software to their community and their customers. To that end, TypeSense is very much like the early days of Silverstripe. The software they created is free, but they are also a software as a service company that uses their own tool to deliver a service. When using their SaaS offering, they offer a globally distributed hosted cluster for your TypeSense collections, horizontally scaled across multiple regions. This allows TypeSense to offer the fastest possible search experience for your customers no matter where in the world they are, as the nearest node to the user is the one that services the request. TypeSense themselves describe this as a CDN for extremely fast search. Indexing happens one time, and the collection can be updated and pruned at any point via an API call. The indexing process itself is extremely fast, which is possible due to TypeSense's native ability to use multi-threading while also taking advantage of a GPU if one is present. TypeSense nodes can be replicated for redundancy and high availability, even when self-hosting, so you can globally distribute your search collection to offer an extremely fast user experience to anybody in the world. From my own testing, I was able to load 2.2 million New Zealand addresses into 500 megabytes of RAM in less than 6 minutes. TypeSense themselves have reportedly achieved 2.2 million recipes in 3.6 minutes, and at the higher end, they have indexed 28 million books in 76 minutes using 14 gigabytes of RAM. On the query side of things, using a data set with over 3 million Amazon products, TypeSense was able to achieve a throughput of 250 concurrent search queries per second. This is an incredible feat that offers an excellent user experience for all of your users. So what does curated search mean? It means that you have fine-grained control over the order of your search results. Sometimes you want certain results to appear ahead of other ones, or simply promote one product over another one. In Solar and Elastic, this is commonly called elevated querying. For example, perhaps you have an online store with a number of different products on offer. But for this weekend only, they are having a sale where they want to promote specific items over other ones. This is achievable with TypeSense curations. Using TypeSense, when any of your users searches for a phone, you can curate your search results to ensure that a particular type of mobile phone appears ahead of all the results for that phone, or an Android, or an iPhone. You can use this feature to change the order of results for specific search terms by placing more favorable products towards the front of the list. Of course, sometimes the opposite case is true, and you actually want to exclude specific results from searches that are exposed to your users. For example, when a user searches for Android, you may only want to include products that are currently in stock and exclude or demote the ones that are currently sold out. Perhaps you do ordinarily sell and support them, and you want your users to be able to find more information about that product regardless of the sale. But until they are stocked again, you don't want to rank them highly while the sale is still happening. Using TypeSense's curation feature, you can also remove a specific document or a set of documents entirely from your search and demote it to the bottom of your search results if that's what you'd prefer. Very similar to curated search, synonyms are a feature that is used when terms are considered to be equivalent or similar or interchangeable. There are two types of synonyms, one-way and multi-way, that can be configured depending on your needs. The main difference is whether you have supplied a root word. For example, you can define a multi-way synonym set like Silverstripe, Drupal, and Laravel, which all refer to CMS as its root word. If any one of those terms is included with your query, the others will be included too. However, in a one-way synonym, you might map smartphone to the words iPhone and Android. In this scenario, searches for smartphone would also return results for iPhone and Android, but a search for Android and iPhone would not necessarily include results for smartphone. The relationship is one way. Synonyms can be used in conjunction with curations. However, care must be taken because the curation is processed first. The curation modifies the query, and then synonyms work on that modified query. Nearly every website operator requires analytics to get the most out of their investment and fine-tune it for performance and financial reasons. TypeSense is no different and optionally gathers data if you tell it to. It allows you to do really simple things like tracking the most popular queries on a search collection, but it can also do the opposite of that. No-hit queries are when a user searches for something but does not find what they are looking for. This allows you to work progressively and iteratively with your TypeSense collections to improve your search results over time. One popular use case for this is in e-commerce applications that track not only how often a particular result is clicked on, but also the follow-up clicks that might lead to a successful sale. In conjunction with instant search, TypeSense is able to integrate with most analytics products, including Google and Matomo, by processing JavaScript events with libraries supported by those products. So all of this is really basic stuff that all search products should and often do offer out of the box. There is nothing terribly groundbreaking going on here. There are a lot of products out there, including TypeSense, that allow you to find tiny needles in massive haystacks with a traditional type and query approach to search. The devil was always in those details, and often developers and website operators alike are left wondering what exactly the catch is. This sounds too good to be true, right? I did not travel all the way to Slovenia from New Zealand to tell you about how TypeSense has reinvented the wheel with search and to introduce the next version of Solar. That is not why I'm here. I have come all this way to talk to you about the really exciting features of TypeSense that blew me away the first time that I saw them, features that I believe will truly improve the relationship that you have with search on your website in a way that all of your users and all of your customers will appreciate. That being said, let's begin to explore the really exciting stuff. TypeSense itself is just a server, a daemon running in the background with as few or as many resources as you care to give it. It does not ship with its own graphical control console. However, the community has stepped up and produced a React application that was created by Boris Fischer to easily administer any TypeSense collection, including the ability to monitor your server, your collections, update the schema, issue API keys, define stop words, control your synonyms, and so much more. The dashboard does not actually need to be installed with your project at all. The application can be saved offline and used to connect to any TypeSense server in the world, provided that CORS has been enabled and allows the github.io domain. Of course, you can also simply install the dashboard yourself on your own hosting or a local development system. For example, a local containerized version can be installed alongside your project using Docker, Lando, DDEV, or whatever development tools you prefer to use. You can even iframe it into a Silverstripe model admin for users to manage themselves if that's what you would prefer. TypeSense supports federated search, which allows you to search multiple collections concurrently with a single HTTP request. This is useful for applications like a site-wide search that separately presents pages and documents. These content pages might be categorized by tag, while your individual documents might be faceted with extensions, authors, dates, and other rich forms of metadata. The results are not mixed together. You do need to organize them into sets of results with an interface like a tab panels or some other mechanism like that. But a federated search means that you do not need to run independent queries on each collection or implement multiple applications or different search pages for multiple different collections and sets. When used with instant search, one request is made to several collections at once, and responses are resolved with promises, one keystroke at a time, to give users the perception that their search is nearly instantaneous, responsive, and relevant to what they are looking for. Scoped search allows you to configure collections with role-based access. Users can have their own personal collection controlled by their own API key, which they can then use to search documents that only they have access to. These users may also belong to a group of users who share access to a document but do not necessarily share the same key. To implement a scoped search, each user can be granted a scope key that can only be used to search on a particular collection or only on a specific set of IDs within that collection. Collections themselves can be filtered by an organization and roles within it, and keys can be expired and rolled over every time that a user logs in. This means that you can safely offer a search of protected data to anybody who bears a protected key without necessarily exposing this searchable data to unauthorized or unauthenticated users. TypeSense fully supports geospatial searches, so you can search for records by their nearest latitude and longitude coordinates. This enables TypeSense to support searches with common and powerful GIS tools, such as searching for points within a radius or within an arbitrary polygon drawn on a map by a user, or even the exclusion of that shape. It can be combined with machine learning capabilities and vector calculations to perform nearest neighbor searches, which is particularly useful for applications such as points of interest or enhancing your search by adding context about the specific geographic area that you're searching for. This is most commonly used within GIS applications, such as council planning websites, real estate applications like homes.co.nz, traffic analysis and crash systems, and other map-driven tools. TypeSense fully supports Unicode, which means it can handle text in virtually any language, including those with non-Latin scripts such as Thai, Chinese, and Japanese. It uses language-specific stemming and tokenization rules to process text with a bit of open-source software called Snowball Stemmer, which is a stemming algorithm designed to process and reduce words to their stems. This is all achieved by defining a locale in your collection and handled at the time that your content is indexed. It also supports stop words for different languages at query time and allows a developer or an administrator to define different stop words for different languages. If you have ever used Silverstripe's text extraction module, you will know that Apache Tika is a very versatile content analysis toolkit that extracts text, metadata, and language from virtually anything you can conceivably upload into the Silverstripe CMS. TypeSense is able to utilize Silverstripe's text extraction module alongside Tika to index over 1,000 different file types. Many Silverstripe hosting environments will achieve this with a Java-based binary running locally on their server, and TypeSense can make use of Apache Tika if it is present on that server, or it can make an API call to an endpoint in your containerized application. It can even utilize an existing Sawyer installation for this, which is super useful when undertaking migrations. This is probably my favorite topic of this talk outside of the demos I'm about to show you. TypeSense has the ability to work directly with artificial intelligence libraries and perform machine learning to enhance your search results, and can do so with surprisingly accessible hardware. This is a huge topic that's hard to cover in a few slides, so we will need to stick to the basics, but for now, even the basics are pretty incredible. And TypeSense has the ability to embed machine learning outputs into its results, which enables your users to execute a nearest neighbor search on the most similar documents. But it can also provide context to your search results, which is calculated at index time, either via an API call to a large language model or running on a CPU or a GPU that's been locally hosted. For example, your LLM might read a page for you and provide a summary or give you a new summary based on data that you have prompted it with. When you are searching on an image-based collection and indexing a set of images, for example, you can use TypeSense to leverage an AI to describe what it sees using software like Stable Diffusion or Clip Interrogator. Some LLMs can even transcribe audio and video, which I will demonstrate later in this talk. This is particularly useful when making non-text assets accessible to all users and providing alternative text for your images, which is particularly important when complying with web content accessibility guidelines, provided, of course, that the results are examined by a real human for accuracy, readability, and appropriateness. Accessibility is a topic that is near and dear to my own heart and an important part of the services that Catalyst offers to all of its clients. So this is a huge win for offering an accessible website. Now, this can require a very beefy GPU, either locally hosted or with a cloud service, but you do not need a top-of-the-line NVIDIA GPU to enable this capability. I personally use an old gaming laptop with a 3 GB graphics card when doing machine learning work in my development environment. While TypeSense does work fine with these resources on smaller collections, it obviously benefits from having more. TypeSense will always carry on with using a CPU when one is available. A GPU is not strictly necessary, but it certainly does help if you can afford the resources. But why would you need one at all? Calculating vectors is computationally intensive, and GPUs are much faster than CPUs for this purpose. A GPU will improve the performance of your vector generation, especially on large data sets. Most of these benefits happen at index time, although in some cases, such as semantic or conversational search, your collection will also benefit from having a GPU available at query time. Having a GPU available at index time is very advantageous because it means that you can have a GPU instance specifically for bulk indexing when you need it, but then turn it off and run a cheaper CPU instance for production use to save on costs. TypeSense offers their own training data to use with local searches, but you can also use it with your own models if you have some. It is compatible with OpenAI, Google, and Azure machine learning services, with more and more being added as newer versions are released. But it also works with open source LLM projects such as OpenLlama through the VLLM project. Before we jump into my live demos, there are some key takeaways that I want to leave you with. TypeSense offers a containerized approach that makes it very easy to work with and deploy. It has many important features such as high-performance search, faceting, analytics, machine learning, and so much more. These are all built in and provided to you, so you do not have to reinvent any wheels or build these clever things from scratch. Implementing a custom search form is a thing of the past and best saved for special occasions. Machine learning can improve overall accessibility and also provide a way better search experience for everyone. All of these, when implemented and used correctly, can add up to cost savings for your company and your clients as well. So without further ado, let's get into the demos. The first demonstration is a website called Find XKCD. XKCD is an online webcomic about math, programming, and scientific in-jokes. The TypeSense community created a tool for searching the entire XKCD comic library. We love to cite memes at work, but one that comes up often in my own workplace is the Bobcat one. So I'm just going to search for Bobcat. I know that Bobcats are mentioned a lot in XKCD, and I happen to know the one that I want is an older one. So I'm going to click on the facets that TypeSense generated for me and select 2007. And there it is. That's the one that I'm looking for. Maybe you want the go-to comic where the velociraptor mauls you for using a go-to statement. As I start to type velociraptor, you will start to see it before I finish, and there it is. This is a very quick way to get a searchable application up and going without doing much development at all. This is all based on an open source product called Instant Search, which was originally developed by Algolia. TypeSense offers an adapter that feeds data into Instant Search in the same way that Algolia does. As a developer, you only need to provide it with a few parameters and configure the search application, and Instant Search takes care of the rest. This entire website is open source, by the way, with a link available to the GitHub source code at the top of the page. You can inspect the source code for yourself, which helped me greatly when developing my module. Next up, I want to demonstrate some things that I have built myself with TypeSense while building my module to make TypeSense work with the Silverstripe CMS. I do not know how many of you are familiar with Resene paint colors, but as a homeowner, I often spend a lot of time at my local hardware store looking at paint swatches and daydreaming about all the colors that I would like to paint my home. If only I had more walls. I use TypeSense to build a tool that helps me name my Sass variables after Resene colors. I think about a descriptive name for colors every time I examine a style guide before I start implementing a theme on a website. I tend to know the Resene colors fairly well, but what I do not know is the hex value for those colors. On Resene's website, I found a spreadsheet that maps all of those colors to RGB values. I wrote a method that converts those to hexadecimal, and now I can search for a color to get the hex code, and that hex code tells me the title of the color that I can use to name my Sass variable. So let's search for quarter T. Oh no, live demo. Tim warned me about this. Yay, backups. The hex codes are all there, and there's also double T and triple T. This website is actually being hosted in New Zealand, by the way, and it is still very fast. I checked that before the talk. So there's double T and there's triple T, so now I can paint my website with Resene colors. And because I'm a huge nerd, I even faceted the colors down to the specific catalogs that they appear in and categorize the colors, so TypeSense can automatically build facets for me. This tool takes advantage of TypeSense's automatic scaffolding. I've only defined the facets, and the software does the rest. Look at all that code I didn't have to write. I've also created an address tool that allows you to rapidly search through all of New Zealand's 2.2 million addresses, which is based on freely available data from Land Information New Zealand. It works alongside another open source module that I've created called NZ Streets, which functions as a free alternative to the paid service offered by New Zealand Post. Okay, I have data on this one, so this one's fine. Let's start with the address of my employer, which is Catalyst's Wellington office, which is located at 150 Willis Street in Wellington. Now, I'm going to deliberately misspell it here. As you can see, there are a few different Willis Streets in there, but they're faceted into suburbs and towns, so I'll choose the one in Wellington and realize the error of my ways. So I can see that I should have typed 150 Willis Street. And I know it's not in Wellington Central, it's in Tiaro. So there is the address of my employer. I'll come over and click it, and it gives me everything that I need to know about this address. So it has latitude, longitude, a map to it. And I did all of that without writing any code. I created a page type, and the page type takes care of the rest for me. This is a pretty simple example of TypeSense's ability to optimize for geospatial data, but one that also leverages its ability to search on nested objects. A collection can easily be built to index by the full address, an entire suburb, a town, or the postcode if that data is available. Moreover, at query time, you can search for points nearby to this location, either within a radius or within an arbitrary shape drawn on a map. Let's move on to what is quite possibly one of my favorite search tools that I've ever created, an audiobook search. Recently, I got an audiobook for free from audible.com. I love audiobooks because they allow me to listen to them while I cannot necessarily bury my nose in a book. I can use them when I'm driving or walking my dog, having a shower, or even just sitting by myself in a dark room. This is great because I have trouble learning from sound alone. For me, I need to look at the text of the book and actually see what I am hearing in order to learn the material. This particular book, however, was audio only and did not come with a PDF. Obviously, I needed to solve this problem. So with a bit of open source software from OpenAI called Whisper, I got a transcript of the book faster than I can listen to the book myself, and I did not even need to cramp my hand to do it. That in itself is really cool, but I noticed that it produced the transcript as a tab-separated file that TypeSense was able to easily index. So I wrote a quick script that parsed that transcript line by line and fed it into a TypeSense collection. The result is that I am able to search for when in an audiobook my search term is mentioned. As an example, I created a bunch of audiobooks found in the public domain and created a searchable Jane Eyre. If you search for "human beings must love something," you will find that the quote starts at 57 minutes and 47 seconds. If I open VLC and skip to that moment, you will hear precisely when in the audiobook that quote occurs.
I would take hers. Georgiana, when not unburdening her heart to me, spent most of the time in London,
jumped to the wrong time.
fretting.
Anyways, I can assure you it does start at 57 minutes and 47 seconds. I'm not sure why it jumped 9 hours into the audiobook. Incredible, right? It gets better. While having an AI read an audiobook to produce useful results for me is a very useful tool on its own, I also notice that it works well with other audio sources, such as recorded speeches, interviews, and online meetings. So before I agreed to do this talk at StripeCon, I presented an informal talk at Catalyst about TypeSense first, just as a way to kind of practice my talk and figure out where I wanted to go from there. That talk was recorded, but there was an issue with the microphone that produced unusable audio. See, the humans in the room had a really hard time hearing it, but when I ran the video through Whisper, the AI detected it nearly perfectly and produced a transcript that I was able to use to re-record the audio and dub over it for that video. As I mentioned earlier, this is a huge win for accessibility because it means that I can produce a completely searchable transcript automatically alongside a video to save the human content creator a bunch of time. The last thing I want to show you before exploring the module itself is a federated search I have implemented inside of the CMS itself. This feature uses the TypeSense module that I have created to search for content on my website that I need to edit quickly. It replaces a search box found on the Pages section of the CMS and covers every bit of content that has been indexed by a collection in TypeSense. It identifies all of the currently defined collections in the CMS and automatically scaffolds them into a searchable form using instant search, as well as the form styling that is inherited from the CMS itself. Watch as I search for open source, or a color in my Resene color picker. That's probably not going to work because I don't have it locally saved. Yeah, so there's no color there. But I'll search for the Jane Eyre one, human beings must love something. And if I come over and click on that, it's going to, oh, of course I'm not logged into my CMS. Live demos, man. That'll take me directly to the record that I use that I can go and edit the content. I can run TypeSense syncing again to update the collection, and it'll be available on my website instantly. Thank you. So you may have noticed the little TypeSense model admin has appeared at the bottom of my screen. So I have a little TypeSense model admin here. So let's explore that a bit. You can see here you can see a list of all the collections I've defined inside of the CMS. So as part of my module, I've built two ways to do this. There's a YAML approach that you may be familiar with from other search products. And there's also a CMS-based approach where you can define a simple collection, such as Pages, right inside of the CMS without involving a developer. Once the collection is defined, you can also define fields with many options pre-selected for you. So I'll just select Pages first. You have many options pre-selected for you and some basic validation to cover simple limitations like sorting on objects or arrays. You can define synonyms directly within the CMS and update a TypeSense server as easily as saving a record. So you have the update TypeSense collection and delete from TypeSense down at the bottom. This module is open source and available at Codeberg. I'm constantly improving it and looking at ways to extend it. If you'd like to help with contributions, be it with code or translations or documentation, I would love to see the awesome things that people have created with it. So who's excited about TypeSense? It is such an awesome product, and I hope you have all enjoyed it as much as I do now. Now, this talk was not intended to be overly technical, so I have saved all the technical stuff for the very end of the talk. Now, this is a developer conference, so I have gone into a little bit more detail than usual, but to be honest, even if you are not a technical person and you've never done search before, it's not very intimidating. The configuration schema has been designed to be straightforward, readable, and easy enough to understand for anybody to get the basic idea of what a collection is doing. TypeSense provides SDKs for PHP, JavaScript, Go, Ruby, Java, and so much more. Even if all you've got is a terminal and 2 thumbs, you can do this with Rust or even curl if you'd like. TypeSense provides an adapter to integrate with Algolia's instant search, which is also open source, so you can start using both by downloading 2 libraries and loading them directly into your browser. This does not require any sort of JavaScript compilation tools, though you can certainly use them if your application requires that. Instant search itself can be a little bit intimidating to configure and use initially, but the documentation for it is very rich, and the learning curve is not particularly steep. One thing I found helpful was creating a Silverstripe page type to configure instant search for me, which meant that I did not need to define a custom form for every collection that I made. The page type that this page type powered all of the demos that I showed to you earlier. Collection schemas themselves are pretty simple, based on JSON-L, which is a list of JSON objects separated by new line characters. You do not need to know much about JSON to understand what is going on here. Reading it quickly, you can see that this schema is about companies. Companies have a name, a number of employees, and a country, and we want to sort by the number of employees. The country is faceted, so you can further filter employees by that country at query time. The schema is designed to be readable, simple, and straightforward, even to a layperson. Your project manager or business analyst could have defined this schema for you as part of your acceptance criteria, and a developer could then implement it with small changes or no changes at all. Everybody is on the same page, and implementation details are not confused or lost. Sometimes rigid schemas are not your thing, and you're just feeling lazy, particularly when you are just prototyping something and do not want to spend a bunch of time and effort doing things like normalizing or sanitizing your data. TypeSense provides something called automatic schema detection, which is not only for the lazy, but also the pragmatic. This means that you can sit back and let TypeSense do the driving while it does its best to make sense of the chaos that you've just fed to it. It will automatically infer the type of data that it ingests and produce a fairly usable collection. All of the field names and the facets are based on regex, so you can describe them as loosely or as strictly as you want. Of course, it is not always that simple. Your data does need a little bit of coaxing from time to time to get the result that you want, but it still does a pretty good job of working with what it's got. Automatic schema detection is particularly useful when your data is disorganized or poorly structured. Sometimes you simply do not know or cannot know what to expect in advance. You do not need to know how orderly or sorted the collection is, so all TypeSense can do is do its best to figure it out for you. Good examples of this are when a website has 20 different page types, all with varying numbers of fields on them. You do not need to distinguish them as particular page types. TypeSense can accept them as objects, and TypeSense will build a collection out of it. It also works great for things like untyped data or users with inconsistent information, such as multiple emails, historic addresses, and things like that. TypeSense makes something sensible for you out of that madness and produces a collection that either just works or one that you can iteratively build on. If you need any more information about TypeSense, there are some resources for you to look at. There is rich documentation hosted at typesense.org, and if you want to learn more about the cloud product or simply use their paid managed service, you can purchase a key and a globally distributed cluster of collections at cloud.typesense.org. As I mentioned earlier, their code is entirely open source, and so is Algolia's. So if you know C++ or JavaScript and want to contribute, you can head over to GitHub to get started. Speaking of open source, I have released my Silverstripe TypeSense module a few months ago. It is open source, and anybody can freely use and contribute to it. I am always happy to review contributions and would welcome any help and ideas that you may offer. Of course, if you do need help building your own search application, I am always available for a chat on Slack or GitHub or through my website. I'm looking forward to helping you out with whatever clever application that you're keen to create. Before I wrap up this talk, I want to personally thank and acknowledge the many people who helped me stand here in this room today. This trip nor this talk would have been possible without the support of these people and my company they've offered me. Special thanks to my wife, Rosemary, for all of her support, and my little sister for looking after my child so I can attend this conference. For Catalyst IT in Wellington for allowing me to travel on company time, and to my mom and dad for being so supportive of me and helping me get to where I am today. I would also like to thank David Malone for helping me with my website and answering all of my dumb questions, and for Simon Erkelins, who many of you know as FireSphere, for helping me with technical feedback and the CSS that I used on this highly entertaining slide deck. Finally, a special thank you to all the open source developers out there that produce the software that I use today. You enable so much while asking for so little. The world is a much cooler place with you in it, and I think it's important to acknowledge that. Thank you again for listening to my talk, and I look forward to having a chat with you all later. Ka kite.
Thank you, Elliot. Any questions for Elliot? Huh? All right. Can we take the mic? All right. Is this one working? All right. Can you raise your hand? Huh?
Thank you very much for your talk. If I understand correctly, there is an automatic update if I save a data record and it's updated in TypeSense?
Yes.
Okay. Have you considered how it is about relations? So if there's a relation added or removed, is there a solution for this as well?
I haven't tried that, but it should work. I can't think of any reason why it wouldn't. It's hooked into on before write. So as soon as it is written, TypeSense will automatically update. Rather, Silverstripe will send an API call to the TypeSense collection and update it that way. I'm pretty sure that will work, but I haven't tried it myself.
Okay. Thank you.
Great. Thanks. Thanks. Anyone else? Any question? Elliot, I'm actually writing a book, an oral history. Does it work? The Whisper, does it work in Slovenian language?
Yes, actually it should. It will read Slovenian. It won't translate it to English, though.
Right.
There's another version of it that does translations that I haven't used, but I think somebody here is talking about it later, so I'm excited about that.
All right, great. Anyone else? Anything for Elliot? All right, see you. Thanks, Elliot. Big round of applause for Elliot.
Ka kite.